Thank you for your interest in Barron Associates' Spatial Disorientation Skills Assessment tool, which has been designed to enable deployment of more effective spatial disorientation training for pilots, addressing one of the leading causes of accidents and fatalities in both military and civilian aviation. Barron Associates is a small research and development company developing novel algorithmic technologies for aerospace, defense, and healthcare customers. Our products include advanced guidance, navigation, control, and autonomy software, modeling and simulation tools and methods, and signal processing techniques. We also have extensive experience developing software implementations of our technologies, including embedded implementations, and developing hardware ranging from biomedical sensing to small unmanned air vehicles. The current work leverages our expertise in both aerospace and biomedical engineering, including experience developing pilot training and pilot aiding technologies, and biomedical sensing and signal processing capabilities. Spatial disorientation is a long-standing problem in aviation and remains a leading cause of aviation fatalities. A causal factor in a third of aviation accidents, spatial disorientation is correlated with hazards, including loss of control, loss of situational awareness, and controlled flight into terrain. Spatial disorientation accidents are nearly always fatal, and some researchers argue the impact of disorientation in mishaps may be higher due to underreporting in accident investigations. Military and civilian aviation enterprises, including the United States Navy and Marine Corps, train pilots and aircrew specifically on spatial disorientation to mitigate the associated hazards. But are these methods effective? Currently, there is no gold standard for measuring the knowledge, skills, and abilities relevant to spatial disorientation hazard mitigation. Specifically, the Navy solicitation for this research effort identified that little research has been done to address the measurement of knowledge, skills, and attitudes required to combat a spatial disorientation incident. The Navy is thus seeking rigorous identification of the key knowledge, skills, and attitudes necessary to mitigate spatial disorientation hazards, development of a software tool for assessing the relevant knowledge, skills, and attitudes, and psychometric validation of that tool, including human participant testing. The tool should be capable of differential measurement to assess training effectiveness, resulting in validated training methods. The tool should also be applicable to a wide range of platforms, including fixed-wing, rotary-wing, and tilt-rotor vehicles. To meet the Navy's need, Barron Associates is developing the Spatial Disorientation Skills Assessment Tool, or SDSAT, which is a software-based tool designed to operate on portable, low-cost, commercial off-the-shelf hardware, making it easy to deploy in a wide variety of settings. The tool employs three main components, which mirror the pilot assessment steps typically followed to achieve a new rating. The assessment begins with written questions, which cover basic knowledge related to spatial disorientation, including knowledge of spatial disorientation hazards that can be encountered in flight scenarios in which these are likely to arise, and knowledge of the physiological mechanisms underlying these hazards. The second stage of the assessment is a scenario-based oral examination, where a human instructor interacts with the test subject to assess their ability to apply spatial disorientation knowledge effectively in the context of realistic flight scenarios. The third stage involves a virtual reality assessment, which includes flying tasks based around realistic flying scenarios, where students are evaluated on both quantitative and qualitative metrics. Secondary tasks are introduced in some scenarios to increase workload and more effectively reveal differences between pilots. The second VR component leverages non-flying VR tasks to isolate and assess critical low-level sensory processing skills. For example, one such VR task assesses pilots' ability to maintain visual fixation in a high optic flow environment, which is relevant to maintaining an effective instrument scan when flying through a broken cloud layer. When SDSAT is used before and after traditional training programs and/or new training regimens, decision-makers can utilize that differential assessment to quantify and compare effectiveness of the instruction. SDSAT can also help monitor fleet proficiency and the appropriate frequency of recurrent training. Like any tool that measures human learning, ours needs to be validated through a series of human participant tests, which will leverage motion simulators as a gold standard measure of spatial disorientation hazard mitigation. Note that these motion simulators are used only for validation and not needed for SDSAT implementation in the fleet. During the Phase 1 effort, we developed the high-level design of the SDSAT tool with representative written, oral, and virtual reality criteria. Because spatial orientation is a mental task, we also had to consider what psychological measures, or psychometrics, we could use to demonstrate that the tool worked. Finally, we identified representative motion simulator tasks. Because motion simulators are expensive and in fixed locations, they are not desirable as a portable and low-cost solution for end users, but are a powerful validation tool because they can stimulate realistic vestibular illusions. In early 2025, we completed an initial prototype of the full software tool, along with a baseline set of motion simulator validation tasks. Necessary protocols and applications have been submitted for the planned human participant tests, allowing us to focus the second year of the base effort on feature enhancements for both the SDSAT tool and the validation tasks. The Phase 2 option year, tentatively scheduled to begin in early 2026, will focus on human participant testing. Working with our partners at Oklahoma State University and the University of North Dakota, both of which have large flight training programs, we will have the opportunity to conduct an extensive series of tests with sufficient test subjects to validate and refine the tool, and compare SDSAT scores against performance on the gold standard motion simulator tasks. We will also use SDSAT to perform a differential assessment before and after traditional spatial disorientation training, conducted as part of the University of North Dakota curriculum, and monitoring pilot evaluations at different training milestones to assess how well our tool can capture the expected progression of spatial disorientation-related skills. What makes SDSAT such a unique assessment tool? Our approach tests all of the domains of learning, including the cognitive, or thinking, affective, or feeling, and psychomotor, or how the brain and body communicate. SDSAT can be used by rotary, fixed-wing, and tiltrotor platforms, while including criteria tailored to the different types of platforms to ensure the highest relevance. Our innovative use of virtual reality allows the tool to assess both piloting skills and foundational sensory processing skills that enable key piloting tasks. And we've created a design that employs low-cost portable hardware. These features ensure comprehensive and rigorous evaluations of pilots that are also rapid and cost-effective. SDSAT fills a key capability gap and will enable the Navy and other aircrew training organizations to make evidence-based decisions about spatial disorientation training that maximize the gain in relevant skills, given the available time and resources. This will support tasks including selection of training programs, determination of recurrent training intervals, and identification of pilots who would benefit from supplemental training, ultimately enabling SDSAT to help the Navy reduce accidents, save lives and equipment, and maximize mission effectiveness. The Phase 2 effort will support comprehensive validation of SDSAT in the civilian pilot training population. We are actively working to identify opportunities for demonstration and validation of the tool with Navy pilots, instructors, and acquisition decision-makers. If you're a military or civilian instructor or aircrew that would like to help us improve your training, or you work in the aviation field improving safety of flight through instruction, please reach out to us. We want your input. Our initial target customer is the Naval Air Warfare Center Training Systems Division, and we believe the tool will be equally relevant to the Army and Air Force, and will target training organizations in those services as the next potential customers. The civilian flight training market is also substantial, with continued projected growth, and Barron Associates' initial work with our university partners to deploy SDSAT in their training environments will be instrumental in supporting expansion of the evaluation tool into other university and civilian flight training programs. The emerging Advanced Air Mobility Initiative also represents a huge potential market for this technology, since pilot training pipelines will need to support a wide variety of new aircrew needs, while ensuring crew and passenger safety. Funding to support demonstrations, as well as gaining access to naval aircrew for end-user assessments, are keys to transition this technology. Such end-user evaluations can in turn identify additional support for any desired tool enhancements that are identified based on those military evaluations. We will also offer no-cost demonstrations of the technology to civilian flight training organizations to showcase the value of the technology and build a customer base. Please come to see us at the Navy STP Syscom Showcase in Arlington, Virginia on March 11th and 12th, or contact Alec Bateman for additional information. We are eager to discuss how SDSAT can improve your pilot training processes and help to reduce accident rates today.